Welcome to video 2 of the chain rule 3.1, section 3.1. When we last saw our work here, we were focusing on this formula or this equation called y. Y equals this expression, and the expression is in terms of the variable t. And we said, well, that's looks a little bit more complex than this purple equation and then this green equation, right? But what's happening is now when I look at this equation, I have composition going on. And I have composition, that doesn't say composition, that says compositive. We have composition going on because I have an inside function here and here that's inside of an outside function, 3 something to the fourth minus 2 times something. So whenever I see an inside function, I'm going to call it something because it turns out there's a quick way to find the derivative without having to multiply all this out, right? At the beginning, you might say, oh, t squared minus 3 to the fourth. Am I going to need to multiply t squared minus 3 times t squared minus 3 times t squared minus 3 times t squared minus 3? And the answer is no. The chain rule saves us from that. And it says this. When I'm taking the derivative of a function called y with respect to x, and I notice that there is an inside function and there's an outside function. It says take the derivative of the outside, take the derivative of f, with the inside, the original inside still composed, still inside of it, and then multiply it by the derivative of the inside. So this is saying, if you can identify what your inside is, to make it less complicated, why don't we call the inside u? And then we're going to take the derivative of the outside with that u expression still in there, times the derivative of the inside, which is the derivative of u. Our goal in this video is to identify what is the inside function, because if we can do that, then our work is going to become a little bit easier. We only use chain rule whenever we have composite functions. That means there's an inside-outside relationship in the function. So we're always looking for stuff inside parentheses. I call it the something, right? And so usually dead giveaways are parentheses, right? Or radicals, whenever there's a square root. Well, whatever's inside, that's probably the inside function. Whenever we have exponentials, the exponent of the exponential is usually the inside. Remember that we only take one derivative at a time. So we take the derivative of the outside, with the inside still the same inside. And then we multiply by the derivative of the inside. So I'm going to go here. I'm going to skip my recipe here, the guidelines. I do want to point out this tip that Brian gives us. Whenever you see an exponential, whether it's e to the something or 10 to the something or 2 to the something is the inside function. That's what we're going to call u. Okay, so here our goal in this video is, can we identify the inside function? So when I look at example 3, what do you think, if this is my function, my complete function, what do we think is the function that's inside of another? We're only focusing on the inside function, the inner function. What do you think it is? I noticed there are parentheses, so maybe this is the inside function. So I'm going to call it u, and I'm going to say u is 2x minus 3. And that's all we're doing, right? We've identified the inside. Can we take the derivative of the inside? Well, we can. The derivative of the inside, and I'm going to use a different color since it's a different expression, or it's a different meaning for the expression. The derivative of 2x minus 3 is 2 minus 0, but I guess I don't need to write the 0. So that would be the derivative of the inside. And that's all. That's all we're doing. We're just identifying what is the inside function. Okay, let's go to example 4. Do we have an inside function? What gives it away that it's an inside function? Look for parentheses. Look for some kind of grouping symbol. So here, this would be my inner function. I'm going to call it u. Can I take the derivative of the inside function? Sure, I can use the power rule twice. The derivative of 3x is 3 minus The derivative of 2x squared is 4x. This expression in orange is the derivative of the inside function in green. Now, we haven't finished it, right? But we're going to make sure that we can identify what's the inside, what's the outside. And we're starting by what's the inside. I'm going to skip through the rules here, and I'm going to go to the next page that has examples. All right. Can we identify the inside? Any guesses on what the inside is? I see parentheses. Maybe the inside is 4x minus 1. Notice that I keep saying maybe because sometimes we think that's an inside, but it might not be. But once we start doing the chain rule, we quickly figure out, oh, yes, it is. Oh, no, it isn't. We'll figure it out. What's the derivative of 4x minus 1? I believe that's just 4 minus 0, so it's just 4. So far, so good. Ooh, what's the inside? Well, I see a radical. I see a square root. By the way, the symbol is the radical. The operation is the square root. So I'm using the radical symbol to signify taking the square root. But inside of that, we have x squared plus 3. Can I take the derivative of that? Sure. The derivative of x squared plus 3 is 2x plus 0, which is just 2x. So far, so good. I think finding the inner function might be not so bad. It really is a key step. If you can identify which is which, you're in the positive here. All right. All of this is inside of the natural log. So all of this is my u, and my u represents the inside function. Can I take the derivative of that? Sure. 8x minus 5 plus 0 would just be 8x minus 5. This seems like it's going to be easy, right? What's the inside function? Remember Brian's comment about exponentials. The exponent is always the inside. So the exponent, I don't see any grouping symbols, right? There aren't any parentheses that can help me out. There isn't a square root symbol that can help me out. All I have is an exponential, and maybe that's the inside. Okay. We're going to find out here in a little bit in the next video if it is or not. The derivative of 2 is 0. The derivative of 5x is 5. So 0 minus 5, that's going to be negative 5. That's the derivative of the inside function. And then finally here, what is the inside function? I think it's x cubed. Take the derivative, 3x squared. So in this video, we're identifying the inner function, the inside function of a composition. That's all we're doing. What's the inner function? F of x. What's the derivative of f of x? F prime of x. And that's where we're going to pause here. So the whole idea here is identifying the roles of the function. Who's the inside function, who's the outside function, is going to be key in applying the chain rule. In the next video, we're going to apply the chain rule to find the derivative of all of these functions that might look a little bit complicated, but it turns out it's not as bad as you think.